Good morning or afternoon, depending on when you're watching this, everybody. Sorry I can't be there today. Charlotte is sick, so I have to stay home with her today. So this is the best that I can do for you. We are starting chapter 7 today, which is rational functions. And like I've kind of previewed a couple of times, if you are paying attention when I tend to ramble at times. But this chapter that we're starting right now is, like I said, called Rational Functions. It is a combination of fractions, because, rational, ratio, fractions, functions. So we've got kind of polynomials mixed in with our fractions. So that is going to be some skill that needs to be reviewed factoring wise once we get to that. Luckily enough, that's not for this first section. For today, we're just dealing with two different things surrounding something called variation. So, kind of how different terms relate to each other that will set us up eventually for rational functions moving forward. So, today, what we're looking at is two things called direct and inverse variation. If if you've done physical science already, or even chemistry, and I know we've talked about it in physics, actually pretty recently right now, with different kinds of relationships, different kind of gas laws, especially. We have these two different kinds of relationships that are just basically describing how, if I have two variables, x and y, how they relate to each other. So, like one type of variation, this first direct one, tells me that as one increases, so does the other. So as x goes up, y is also going to go up. Our other one that we'll look on the back side of our notes today, inverse variation. Inverse just meaning opposite. As one goes up, the other goes down. So we've got a couple of different examples of this in science, but again, the gas laws is the best place to look at those. Where again, as like pressure increases at a set temperature, then volume is going to decrease. So if I keep the temperature the same, as I increase the pressure, it decreases the volume. So that would be an inverse variation. One thing that would be direct, if you kind of look at those gas laws again, if I keep my volume constant, as I increase the pressure, I would increase the temperature. So in this case, temperature and pressure would be directly proportional because as I increase one, I increase the other. Kind of getting more specifically into the math side of things, you've got the definition there for direct variation. We would say either y varies directly as x, or I could phrase it as y is directly proportional to x. Both of those mean the same thing. If that is the case, that just means I can take some multiplier with x and get my y value. So this is kind of like a linear equation. I'm just going to have a single number in there for k, and I'm just going to multiply that by my x value in order to get my y value. So here, in this case, k is what we'll call the constant of proportionality. That's usually what we'll call it, or the constant of variation. So be ready to hear either of those two terms. Sometimes a problem in the textbook or a worksheet that I give you will present either of those two values to you. They'll describe the constant proportionality as 3, and then if your x value is yada yada, then find your y value. And like I said, this kind of just describes as x gets larger, so does y. As x gets smaller, so does y. They vary directly. So as one increases, the other increases. As one decreases, the other decreases. So this table here is one that represents or kind of presents to us a direct variation. And they want us to try and find the constant of proportionality. So remember, y equals kx, which if I wanted to rearrange that to try and solve for k, since I'm asked to find k, my constant of proportionality, that would just be y divided by x. Right? Just divide by x on both sides over here. Oops, not a 2. Divide by x, and my constant of proportionality is just y over x. So for this one, y over x would be 3 over negative 1, which is just negative 3. Doesn't matter which one you choose here. This 0, 0, that doesn't help us at all in finding our k value. So we're not going to use that one, but either of the other three or any of the other three would still give you that same k value of -3. 6 over -2, 12, -12 over 4, all three of those reduced to just -3. So that's our constant of proportionality. Another kind of problem that they can give us, like I was describing before, they'll give us an example of a pair of points. So they'll say in this case, if y varies directly as x, which means x times k equals y. If x equals 3 when y equals 9, then what is y when x equals 4? So kind of an abbreviated version of that previous problem, and then extending it further. So that first pair, 3 comma 9, is an example of a solution to my equation. So what I'll have to do is use that to figure out what k is, and then apply it to that second piece here, trying to figure out the y value when my x value is 4. So again, if k is y over x, 9 over 3 is just positive 3, so that's my k value. So then over here, if y is 3 times my x value, y is going to be 12 when x is 4. Right. For example number 2, now we've got a word problem version of this. So in this case, when a bicycle is pedaled at a certain gear, it travels 16 meters for every 3 pedal revolutions. How many revolutions would be needed to travel 600 meters? Now this one doesn't tell us necessarily that it's direct variation. This is one where you have to interpret that. Sorry. I've been up for a little while, and as you can see on the clock, it's just now 5 o'clock. So this one, you have to be able to interpret that it's direct variation, which again should make sense to us if we're looking at the number of times you pedal the pedals, so the number of times you revolve the pedals, and your distance traveled. It makes sense that those are direct variation. The more number of times I pedal, the further I'm going to go. As one increases, so does the other. So what we have to do is figure out first what is that k value. So this is still it's very similar to example number 1. I have to find out what that k value is and then apply that to my problem. So I'm going to use some kind of purposeful variables here instead of x and y. I'm going to say my distance is d, and then my revolutions, my number of times I pedal, is going to be r. So I should be able to set up d equals kr, where again, the number of times I pedal, the number of times I turn the gears, times some set number will tell me how far I'm traveling. So in this case, my distance that they gave me was 16 k times 3 revolutions. So if I divide by 3 to get my k by itself, k is 16 thirds, or 5 1/3, 5.3 repeated if you were a decimal person. But in this case, I'm going to leave it like that just so that I have an exact answer. So then what they want me to try and figure out is how many times do I need to turn the gears in order to travel 600 meters. So my equation, once I substitute my k value in there, would be y equals, or sorry, I've used d and r. So my distance is 16 thirds times my number of revolutions. Now here you have to be careful because they want us to try and find how many times I need to turn the pedals in order to travel 600 meters. So I'm going to be plugging in 600 over for d and then solving for r. So in order to do that, depending on your philosophical beliefs, I'm either going to be multiplying by the reciprocal. So I'm going to change this to red so it's easier to see. So I'm going to multiply by 3/16. Or you could say you're dividing by 16 thirds. That's fine too. Either way you do this, let's switch this to a green. So 16 and 3, those reduce. So I just have R equals. For 3/16 times 16, that would be 1800 over 16. It's not going to be very pretty. We got 112 and a half revolutions. Or, 225 over 2, if you want to, 225 over 2, if you want to reduce that. But I'm fine with a decimal if you want to put 200 or 112 and a half or 225 over 2 revolutions. But that would be how many times we need to turn those pedals in order to get 600 meters. Okay. Normally I would have problem 1. I would have you guys just try that on your own, and then we would go through it together. I can do that real quick with you. I don't want to spend a whole lot of time on it because I don't want to make this too long. Basically here, our refund R varies directly with the number of cans that we recycle. So again, here, basically the K value that we're figuring out here, our constant proportionality, is how much we get paid per can for returning it. And then trying to figure out how many cans we need to collect in order to get, or how much money we'll get based on 500 cans recycled. So this information they give us right here, we get $3.75 by returning 75 cans. So that's what will give us our sorry, Mr. H just texted me back. Sorry about that. So here, our refund is based on a K value times the number of cans that we collect and return. So if we're trying to figure out what that K value is, we'll just divide by C. Our K is our refund, which is $3.75, divided by the 75 cans that we have collected and returned, which comes out to 0.05. So basically what that translates to, we get a 5-cent return on every can. So if we apply that, our refund for 500 cans should be $25. Okay. On the back side, inverse variation. Inverse variation, again, kind of like I had previewed before, this is where as one goes up, the other goes down. Or as one goes down, the other goes up. They act oppositely. So this is, again, for those who have done gas laws already, this is pressure versus volume. So if you keep the same temperature, if you increase the pressure on a gas or a fluid, it's going to decrease its volume, right? More pressure, condense down those particles, and I take up less space, assuming that we keep temperature the same. So here, this is what your equation looks like, because again, in order for one to go up as the other goes down, or vice versa, we have to have it set up as a fraction where they're on opposite levels. So in this case, my constant proportionality or my constant variation is now the top of my fraction, and then x is the denominator. So we'll see it this way. We'll also see it where we just have k equals y times x, because the multiplied together should be constant. Because again, as one gets really big, the other one gets really small. So when you multiply them together, it still comes out to that same constant. So finding the constant of variation, all we have to do is multiply them together. Because again, here, like we just talked about, k is just y times x. So if I multiply my x and y values, here I get 12. Hey, look, 2 times 6, we get 12. Without having to do either of these two difficult calculation problems with lots of reducing and stuff, it's going to be 12 all the way through, because 1 times 12 is also 12. So my k value is just 12. So these ones are actually usually a little bit easier to, especially to find your k value. It's super easy to just multiply those two numbers together. For number 1, if y varies inversely as x, and when x is 3, y is 9, what is x when y is 27? So finding that k value, 3 times 9 is just my x times my y. My k value is 27. And so that means my equation is y equals 27 over x. So if I substitute in there, 27 equals 27 over x, then without even really having to do any kind of rearranging, which actually is fairly complicated, at multiplying x on both sides and then dividing by 27, we can just kind of logically see that that x value has to be 1 in order to make that equation true, right? 27 divided by 1 is 27. So that means my x value is 1 when my y value is 27. Okay. For problem number 1 here, find x when y equals 3 if y varies inversely as x, and x equals 4 when y equals 16. So same problem, just written backwards. Don't get freaked out by that. Here they're just kind of giving you the problem first and then the premise second, where example number 1 we had it the other way around. This is still just saying, all right, well, I'm going to use this 4 and 16 to find my k value, and then use that to find what x value would give me y of 3. So here my k would be 64. So 4 times 16 is 64. And then we would go through, plug in my other k value, or sorry, plug in my y value. So sorry, my mind is all over the place right now. This tells me my equation is y equals 64 over x. That's what I get from that second part. Now they want me to figure out what my x value has to be if y is 3. So 3 equals 64 over x. So this one, not as obvious to be able to identify what x would have to be. So the process that I would have to do, first with these, I have to get x out of the denominator. So I would have to multiply by x on both sides. That gives me 3x equals 64, and then I divide by, I'm not going to try and squoosh that underneath there, divide by 3 on both sides, and whatever 64 divided by 3 is going to give me my x value, which in this case is not a whole number. 64 over 3 reduces to about 21.3 repeated. Well, not about 21.3, but exactly 21.3 repeated. Okay, the last one is definitely the most complicated, because if we look at this is another application problem. Again, we see these a ton in your science classes. So in physics, we do talk about electricity towards the end of the school year, and you might cover some electrical stuff, some resistance and things, maybe in physical science, but I don't think so. Doesn't matter. In problem number 2, we're given that the amount of resistance in an electrical circuit required to produce a given amount of power varies inversely with the square of the current. And they want us to see if a current of 0.8 amps requires a resistance of 50 ohms, what resistance will be required by a current of 5 amps. So, some things to just kind of highlight and dissect here. So they're telling me that it varies, the amount of resistance, it varies inversely with the square of the current. So if we use R for resistance and C for current, the amount of resistance varies inversely with the square of the current. So this is why I was saying this one's a little more complicated than we're used to. Usually it's just y varies inversely with x. In this case, y would be varying inversely with the square of x, so x squared. But in this case, we'll use R and C to kind of correlate those two things together. So that tells me that my k value, my constant of proportionality, is my resistance times my current squared. So in the example they gave us, the current of 8 amps, the 0.8 amps is my current, so 0.8 squared. and my resistance had to be 50 ohms in order for that to be sufficient. So if I just use my calculator for that, 0.8 squared, whoops, that's not 5.0, that's 50, is 0.64. 50 times 0.64 comes out to exactly 32. So that K value, that constant of proportionality that works in my equation here, would be 32, just 32. So then, second half of this problem, what resistance would be required for a current of half an amp, so 0.5 amps? Now I'm just going to go to, I want to use this version of the equation, just as a little nicer to look at. So 32 is my constant of proportionality, R times my C squared. So 32 equals the resistance I'm trying to figure out. My current is now half an amp. So 32 equals R times 0.25. So I divide by 0.25. Right, divide by a quarter, basically, so multiply by 4, and I get 128 for my resistance. Make sure for these, you do put your units, so 128 would be ohms. That's the unit for resistance, so 128 ohms would be the resistance required in order to have a flow of, a safe flow of 0.5 amps. That's all I got for you. I'm sorry that last one got a little complicated. Most of them that you'll see today are more like the basic, here's your table, find K, here, and again, kind of example one, problem one type problems. Here are these X and Y values. You know it varies directly or inversely. Find X when Y is this, or find Y when X is this. So your homework, which is printed down there at the bottom of the page, is page 363. 4 through 24, just the evens. 4 through 24, just the evens. Tomorrow, I will definitely have as just being a practice day for 7.1. So if you're confused, first and foremost, go back, rewatch certain sections, listen to me ramble on, probably incoherently at 5 o'clock in the morning, and if you're confused by stuff, do your best on the homework. If it's not perfect, if there's something you're just totally lost on and you can't figure it out after watching it 2 or 3 different times, or asking a friend, looking in the book and stuff, we'll be able to kind of square that away tomorrow at the beginning of class, and then it'll just be a practice day after that. So if you have any really big pressing questions or anything, feel free to email me. I'll try and respond as long as I'm available. So, sorry for rambling that last little part there. Have a great day. I'll see you guys tomorrow.